The 777 flight controls are fly-by-wire. Fly-by-wire is an electronic rather than mechanical system for operating the flight controls. Controls for the flight crew are like other Boeing airplanes, using the familiar control columns, control wheels, and rudder pedals. The flight crew always has ultimate control authority. The flight control computers cannot override a pilot command. Here's how fly-by-wire works. Pilot inputs through the control column, wheel, rudder pedals, and speed brake lever are converted to analog electrical signals. These analog signals go to 4 actuator control electronics, or ACEs. The ACEs convert analog electrical signals to digital signals and digital signals back to analog signals. The digital signals from the ACEs are sent to 3 primary flight computers, or PFCs. The PFCs also receive airspeed data, inertial reference data, angle of attack data, and flap position from other airplane information systems. The PFCs are the brains of the system. They calculate the flight control position commands requested by the pilot and send them back to the ACEs. The ACEs convert the digital signals back into analog form and send them to the Power Control Units, or PCUs. The PCUs provide the muscle to operate the flight controls. The power control units drive the primary flight control system. The primary flight control system provides roll, pitch, and yaw control. 2 ailerons and 2 flaperons provide roll control. The flaperons also provide added lift by drooping when the flaps extend. There are 14 spoilers, 7 on each wing. The spoilers assist the ailerons and flaperons in providing roll control. They also serve as speed brakes. The elevators control pitch. A movable horizontal stabilizer assists the elevators in controlling pitch. A dual surface hinged rudder provides yaw control. Flight controls are checked after engine start in the traditional manner, verifying freedom of motion and return to center. The absence of an ICAS message confirms the system is normal. The flight controls synoptic page gives the crew a graphic overview of the flight control system. Display the flight controls synoptic. The synoptic shows primary flight control surface positions. The pointers indicate movement and relative displacement from center. Notice when the aileron moves up, spoilers on the same side deploy. Two pointers represent the left and right elevators. There is one pointer for the rudder. The synoptic also indicates the position of the stabilizer and rudder trim. The primary flight control system has several envelope protection features. These features operate whether the pilot or the autopilot is in control, or wheel. The protection features include stall protection, overspeed protection, and bank angle protection. To ensure operation of the primary flight control system at all times, the system has three modes of operation: normal, secondary, and direct. When the primary flight control system is operating in normal mode, the autopilots and auto speed brakes are available, and all protection features are available. The primary flight computers and ACES are operating. The primary flight computers automatically switch to the secondary mode if the system detects a loss of airspeed or inertial reference data. In secondary mode, the autopilots and auto speed brakes are not available. Envelope protection features are not available, and yaw damping may be lost or degraded. However, in secondary mode, the pilot retains full manual control of the airplane. The primary flight control system automatically switches to direct mode if other failures occur, or if the pilot selects disconnect with the primary flight computer's disconnect switch. In the direct mode, the ACES disconnect from the primary flight computers and operate flight control surfaces directly from pilot inputs. Control in direct mode is similar to that in the secondary mode. The crew still has full control of the airplane. The high lift control system operates aerodynamic controls to increase lift at lower speeds for takeoff and landing. There are two outboard trailing edge flaps, two inboard trailing edge flaps, and two Kruger flaps. In addition to the Kruger flaps, there are 7 slats on the leading edge of each wing. There are 6 guarded flight control shutoff switches on the overhead maintenance panel. They are for maintenance use only and should be left in normal for all operations. The switches are checked during pre-flight to assure all guards are closed and lights are extinguished.